NASA has just detected rhythmic electromagnetic pulses screaming from the crystallized hearts of dead stars. These aren't just random cosmic noises. They are the ghostly whispers of entire planetary systems that were incinerated eons ago. For the first time, we are decoding the final screams of shattered worlds being pulverized by their own suns. Up until recently, we thought dead stars were just cosmic tombstones floating silently in the dark. But thanks to brand new 2026 data from the James Webb Space Telescope, we've realized we were dead wrong. These dead stars are actively eating the corpses of their own planets, and as they feed, they broadcast a forensic fingerprint of everything those planets used to be. Mountains, oceans, tectonic plates, and maybe even the building blocks of life. We aren't just looking at a cosmic graveyard anymore. We are looking at a hyper-advanced broadcast library of every world that ever existed, and a terrifyingly precise map of exactly how our own Earth is going to die.
To understand what's screaming in the dark, we have to look at what's doing the killing: a white dwarf. When a star like our Sun runs out of fuel, it doesn't go out with a massive supernova bang. Instead, it bloats into a massive red giant, exhales its outer layers into a planetary nebula, and leaves behind its exposed core. Imagine taking half the mass of our entire Sun and crushing it down into a sphere the size of Earth. The gravity is so intense that dropping a marshmallow onto its surface would result in an impact with the force of a nuclear bomb. For decades, astronomers thought these stellar remnants were incredibly boring. Because their gravity is so extreme, any heavier elements like iron or rock should sink below the surface in a matter of days, leaving dormant atmospheres of pure hydrogen or helium. But astronomers started noticing something weird. Roughly 25 to 50% of white dwarfs in our galactic neighborhood are polluted with heavy metals like magnesium, iron, silicon, and oxygen floating in their atmospheres. If heavy things sink instantly, seeing them on the surface means the star is eating them right now. In early 2026, JWST pointed its sensitive infrared cameras at a heavily polluted white dwarf named GD362 and saw a massive, swirling disk of planetary debris stretching hundreds of millions of miles into space. The star is actively pulverizing leftover asteroids, moons, and planets from its old solar system. As this debris rains down, it gets funneled by intense magnetic fields into the star's poles, creating massive metallic auroras. As the star spins, these intensely hot magnetic poles flash into view, beaming rhythmic, highly structured electromagnetic pulses, ghost signals, directly at Earth. To understand why these gravitational death traps ring out like cosmic gongs, we have to look inside the dead star. As a white dwarf cools, extreme pressure does something mind-bending to the carbon and oxygen trapped in its core. It crystallizes. The core of a dead star freezes into a solid, ultra-dense metallic crystal, essentially the largest diamond imaginable. Astronomers study these interiors using astroseismology, watching the star vibrate. As planetary debris violently falls onto the white dwarf, it triggers deep acoustic waves that ripple through the solid diamond-like core, causing it to ring out and pulse in brightness. Surrounding this ringing heart is a massive gravitational wake. When a star dies, the orbits of its remaining planets go completely haywire. And when a planet gets pushed dangerously close to the white dwarf, it hits the ultimate point of no return. When a planet crosses this invisible boundary, the star shreds it at the atomic level, revealing secrets that blow our current understanding of planetary composition out of the water. Astronomers reading these pulses are looking at a chemical barcode. Every element absorbs and emits light at a specific frequency, allowing scientists to reconstruct the makeup of a planet that no longer exists.
telescopes have found the exact chemical signatures of Earth-like worlds in these signals. Heavy iron from terrestrial cores, olivine and pyroxene from rocky mantles, and hauntingly, hydrogen and oxygen in exact proportions that scream water. We are picking up the signals of vaporized oceans, the last geological and potentially biological records of once habitable planets. These signals prove that the building blocks of Earth are common throughout the galaxy. But they also show that these worlds don't last forever.
The mechanism behind this destruction is known as a tidal disruption event. If a solid object crosses a white dwarf's Roche limit, the gravitational pull on its front becomes so much stronger than on its back that it is stretched and shredded into a fine metallic mist. This spaghettification creates a massive debris disk orbiting the dead star.
As the star consumes this mist, the highly conductive metallic plasma interacts with the white dwarf's intense magnetic field, creating a massive feedback loop. The star blasts out high-energy X-rays and radio waves, essentially weaponizing the corpse of its planet to turn itself back on. With data suggesting up to half of all white dwarfs are actively feeding, our galaxy is filled with millions of these screaming zombie stars.
Ultimately, these ghost signals are showing us a mirror and giving us the exact timeline of our own demise. In about 5 billion years, our sun will run out of fuel, swell into a red giant, and swallow Mercury, Venus, and likely Earth, boiling our oceans away in a geological blink. Eventually, it will collapse into a white dwarf. The surviving outer planets and the scorched remains of Earth will orbit this glowing diamond heart until the solar system's gravitational balance destabilizes.
If Earth's charred remains are pushed across the dead sun's Roche limit, our planet will be pulverized into a glowing disk of metallic dust. And then, our sun will begin to scream, broadcasting the chemical signature of Earth out into the cosmos. This discovery shifts our philosophical perspective. The universe isn't a massive, empty graveyard. It's a broadcast library. Long after civilizations fade, the atomic memory of our world will still sing out across the void, waiting for someone in the distant future to point a telescope at a tiny white dot and decode us.
If you enjoyed our content, please hit the like button and subscribe. If you want to know about anything else about the space exploration, write down in the comments and we will explain it in the next video. Until then, goodbye and see you in the next one.